Today, we are going to start out talking about conversion factors, how to set up and work conversions. You'll end up having a worksheet tonight that is dealing with English to metric conversions and vice versa, metric to English. We will also do some temperature conversions. And then finally, we're going to end by discussing accuracy versus precision. Accuracy versus precision. So, conversion factors. Conversion factors are fractions in which the numerator and the denominator are equal, although they are expressed in different units. The example I have given up here is a common one that we see, and it is the fact that 1 inch is equal to 2.54 centimeters. 1 inch is equal to 2.54 centimeters. So these two things right here are the factors, the conversion factors that can be set up because they are equal. Now, as we do so, we could write conversion factors for each of the following. How many liters equal how many milliliters? Remember from our metric conversions yesterday from the sheet? How many milliliters are there in a liter? 1,000. Excellent, Parker. He's not shy. All right. 1,000. So, my conversion factor could be 1 liter over 1,000 milliliters. Or flop it. What about hours and minutes? Hours and minutes. Alex, right? 60 minutes, 1 hour. That could be our conversion factor, or vice versa, flop it. What about meters and kilometers? Meters and kilometers. How many meters are there in a kilometer? Yeah. Nice and loud, Kane. 1,000 meters is equal to 1 kilometer. Those are all conversion factors. Now, how do we use these conversion factors? Here is a question. How many minutes are in 2.5 hours? How many minutes are in 2.5 hours? Well, we need to set up a conversion factor. And folks, when I set up my conversion factors, I put what I call a conversion box. My conversion box would look like that blue right there. So I would have 2.5 hours. All right, and now I just have to decide which way I have the conversion factor. Okay, what goes on the top? What's in the numerator? What's in the denominator? Well, the whole idea is you need to find the label that will cancel. By using dimensional analysis and the factor label method, the units ensure that you have the conversion right side up, and the units are calculated as well as the numbers. Now, as I look at this, I want my hours to cancel. So that means that I'm going to put the hour on the bottom so that those two labels cancel out. What label does it leave me with? Minutes. Then all I have to do is multiplication or division. If it is in the numerator, I multiply it. If it's in the denominator, I divide it. So in this case, I would take 2.5, multiply it by 60, and then divide it by 1. Well, do I need to divide it by 1? We know that answer, don't we? So in this case, and you might as well get out your calculators. We're probably going to use them here. So in this case, I just take 2.5, multiply it by 60, and that would give me 150. And my label would be the label I have left over, the minutes right there. Transfer over to there. Now, that's not terribly tough. Okay, it's not terribly tough. It gets more confusing when we start dealing with labels that we're not used to. Okay? It starts getting more confusing when we're dealing with labels we're not used to. Now, you need to go ahead and write this down because this is how we do these conversions. So, okay, as we are going through and reading this, it's just a sort of a step-by-step explanation of how to solve these. I know a lot of the times folks want concrete directions. Okay, the first step is to write down the given amount. Don't forget the units because the units are very important. You need to multiply by a fraction that is known as the conversion factor. Determine if the top or the bottom should be the same unit as the given so that it will cancel. Put a unit on the opposite side that will be the new unit. If you don't know a conversion between those units directly, use one that you do know. That is an intermediate step. Insert the numbers on the conversion so that the top and the bottom amounts are equal, but in different units. Multiply and divide the units, which cancels out your units. If the units are not the ones you want for your answer, make more conversions. That is, if you have an intermediate step. And don't forget, okay, when you multiply and divide the numbers, don't forget order of operations. And I was always taught, please excuse my dear Aunt Sally as my order of operations. Do not forget the order of operations. Now, as we are doing so, we can do sample problems. All right? The very first sample problem if you have $7.25 in your pocket in quarters, how many quarters do you have? How many quarters do you have? I need to set up my conversions. I do so by writing down my given and then setting up my fraction. My given was $7 and my fraction. And like I said, I want you to make conversion boxes as so, like I have drawn up there in blue. Now, on my conversion box, I need to make sure that dollars cancel. So I put dollar on the bottom. On the top goes the quarters. Well, I know that 4 quarters equal $1, right? So, do I get my dollars to cancel? Absolutely. One's on top, one's on the bottom. $1 over $1 is 1, right? Anything over itself is 1. So $1 over $1 is 1. So my new label is going to be what? Quarters. So I simply take 7.25 and I multiply it by 4, and that gives me 29 quarters. All right. You've just made a conversion. Write this one and answer it. It's a little learning check. Go ahead and write this down and answer it. See if you can do it. So we know our conversion factor is 3 feet in the yard, right? So what's that going to be? Okay. How are we going to set that up? I would sit here and say, okay, 2.5 yards is how tall that Jacob and Spencer are together. My conversion factor, I set up my conversion box, and I know that I want yards to cancel. So 1 yard is 3 feet. My yard cancels, my yard cancels. So I take 2.5 and I multiply that by 3. What do I get? 7.5? That sound right? What's my label? What's my label? Foots. How about feet? How about feet? 7.5 feet is now my conversion. Here's another one. You don't necessarily have to write down the question, but answer it. Okay? This is a metric conversion. A rattlesnake is 2.44 meters long. How long is the rattlesnake in centimeters? Metric conversion, if you don't remember your metric conversion, you got a chart you wrote down yesterday. Look at your metric conversion chart. How do I go from meters to centimeters? I'm jumping what, where? I'm jumping what, where? The decimal to the right 2 times. So what's my answer going to be? Letter B, 2.44 centimeters. All right. Now, if you're using the actual conversion factor on the factor label method, you would set it up as so. Here we go. How many seconds are in 1.4 days. Now, the reason that I put this up here is because this is a multi-step one. Okay? Multi-step. I have days. I have to convert from days to hours. Okay? Hours to minutes. Minutes to seconds. Go ahead and try that, and then we'll answer it here. Here I go. I know that there are 24 hours in a day. So now I've converted that to hours. Now look at this step here. Okay? Let's go back here first of all. I've converted this to hours. What's my next step now? I need to go hours to minutes. So when I set up my conversion factor, I want hours to cancel. So I have 1 hour, 60 minutes. I've now converted that to minutes. I don't want minutes though, I want seconds. So I need to do one more step. So I know that 1 minute has 60 seconds. My minutes cancel. My final answer is going to be in seconds because that's the only label that I have that did not cancel. So I take 1.4. I multiply that by 24. Multiply it by 60. Multiply it by 60. Do I need to divide by anything? No, because it's all 1. So I come up with the answer of 120,960 seconds. Final answer, because we have not talked about significant figures yet. How many significant figures would be here? How many significant figures? 2. Okay? 2 sig figs. You go back to the original 1. So that would be 2 significant figures. We'll talk about that tomorrow. Now, flipping back over to this one. What is wrong with the following setup? Brooke? Do I have right here, do I have a cancellation? I do not. So I have set that up wrong. Now, people, pluggers, okay? I warn against being a plugger. What that is, and I've seen people already today doing it, that is the person that doesn't have any work and just sits here and plugs numbers in the calculator. I recommend highly against pluggers because if you're a plugger, do you see you made that mistake right there? Do you see that your hour and days are flopped and that they do not cancel? Do you see that, Kane? No, you do not. Thank you. That is why I recommend against being a plugger. I've done this 20-some years, folks, and when I answer that question, I write it all out exactly. Okay? The reason I do it is a lot of the times my mind gets working faster than I can write stuff down, and all of a sudden I might flop something. If I wrote it down, I can see it. Okay? I can see it if I write it down. And I say, whoa. I look here, and I go to cancel my day, and I put a swipe through that day, and I go, wait a second. An hour doesn't cancel out a day. I've done something wrong. I go back, I correct it. Okay? If you're a plugger, you never see that happen. All right. A lot of the times, too, people don't put labels. What do I mean by that? They just do this. They say, okay, 1.4, 124, 61, 61 equals. Okay, do I see any labels canceling there? Huh? I know I flopped them. Okay, I wrote it just like here. Do I see any labels there? Can I tell that they don't cancel? No. Okay, it's the same thing. If you don't write labels like that, it's the same thing as being a plugger. You're not helping yourself try to recognize your errors if there could be one. Okay? So, don't just be a plugger. Let's talk a little bit about English and metric conversions. English and metric conversions. They're no different. If you know one conversion factor for each type of measurement, you can convert anything. Now, the ones up here are some ones that I think you should memorize because you're going to probably see those often. Okay? They're some of the more common ones: mass, length, and volume. 454 grams is equal to 1 pound. We've already discussed the length. 2.54 centimeters is equal to 1 inch. And the volume, 0.946 liters are equal to 1 quart. All right, we have to go an intermediate route. So, my plan is to convert liters to quarts, then convert quarts to gallons. Liters to quarts, quarts to gallons. So, I'm going to write it up here because I've got more room. 4.65 liters. As I convert that to quarts, what do I want to cancel? Liters. So I put 0.946 liters on the bottom, 1 quart on the top. Finish up my conversion box. Now, I cancel my labels that can cancel. Liters cancel. I have now converted that into quarts. I don't want quarts, though. I want gallons. So I have to continue on my conversion box. I want quarts to cancel. I know that I have 4 quarts in 1 gallon. My quarts then cancel, leaving me with the label of gallons. Now I just have to work my math. This one's a little bit different. Okay, this one's a little bit different because I have it in the denominator. So what I do is I take 4.65. I could multiply by 1, but that's not going to do me any good because it's still going to give me 4.65. So I take 4.65, I divide by 0.946. Then I hit execute, or enter, I guess it is. And then I divide it again by 4. Once I do that, I come up with the answer that 4.65 liters is going to convert into 1.23 gallons. Now I've rounded that number. Why did I round that number? I rounded that number to 3 significant figures because I have 3 sig figs up at the top. But once again, sig figs are tomorrow. We'll worry about sig figs tomorrow. But that was a 2-stepper with intermediates. What do you think? We have thumbs up here? We okay? We're going to get some practice with it tonight. Okay? We're going to get some practice with that tonight or today or in a little bit. Now let's talk a little bit here about these equalities. State the same measurement in 2 different units. Could we do that? Well, here's a ruler, and on our ruler, we have 2 different sides of a ruler. We have centimeters on the bottom. We have inches on the top. So I could make a measurement in 2 different units right there. It looks like it's 10 inches. How many centimeters? Well, it says millimeters. Centimeters is 25.4. Okay. Well, it makes sense because we know 1 centimeter is 2.54, or excuse me, 1 inch is 2.54 centimeters, right? Multiply both of them by 10. Yeah, that makes sense. Now, you've already wrote that down. You already wrote that down, so I'm not real concerned about you putting this down again. It's just a condensed version of what you wrote down. Now, we're going to talk about temperature scales. You're familiar with Fahrenheit, all right? You're familiar with Fahrenheit. That's what we measure things in here in the United States. I've got a little temperature gauge right up here that's telling me that we're about 78 degrees Fahrenheit in here right now. What are the other scales, though? Celsius and Kelvin. Now, believe it or not, and I think I put this in here. Yeah, there we go. Anders Celsius. So the Celsius scale is actually named after a gentleman, Anders Celsius. What do you think? Is Kelvin named after somebody? Probably. I think you're probably right. Lord Kelvin, which I don't know why it's Lord Kelvin, but hey. I don't know about Fahrenheit, but I would guess so. I don't know. Maybe I'll have to look into that. Maybe I'll Google that here in a little bit to see. Temperature scales, boiling point, freezing point. Boiling point, freezing point. In Fahrenheit, what's the boiling point? What's the freezing point? Anybody know? Boiling point's 212, freezing point is 32. Okay. What about Celsius? 0 and 100. Okay. What about Kelvin? Kelvin's the crazy one. Okay. Kelvin's the crazy one. It is 273 and 373. (273) and 373. So those are the boiling points and the freezing points on all 3 of the temperature scales. Now, what are we going to do with these? Okay, well, I guess we should make a point here. Notice that 1 Kelvin is equal to 1 degree Celsius. 1 Kelvin is 1 degree Celsius. In between their boiling and freezing points, there are 100 units, whether it's 100 Kelvin or whether it's 100 degrees Celsius. And what makes another point, okay? Do we say 100 degrees Kelvin? For some reason with the Kelvin scale, we just say Kelvin. We don't put degrees, okay? It's degrees Fahrenheit, it's degrees Celsius, but it's just Kelvin. Now, when we're doing calculations, we generally use the Kelvin scale. I told you why earlier in the year. Does anybody remember? What's the advantage of using the Kelvin scale? It does not have negative numbers. Excellent. Okay? The Kelvin scale does not have negative numbers, so that's why we generally use it. Now, in order to convert from Kelvin to Celsius and vice versa, we use the number 273.15. So if I have a temperature in Celsius, I add 273.15 to convert it to Kelvin. If I have a temperature in Kelvin, I subtract 273.15 to convert that to Celsius. So, Kelvin to Celsius, Celsius to Kelvin is just a matter of adding and subtracting. Example, our body temperature is roughly 37 degrees Celsius. How much Kelvin? Well, we add 273.15, which I didn't do there. I just did 273. So the answer is going to be 310.15 Kelvin. Liquid nitrogen. Liquid nitrogen is negative 196 degrees Celsius. So nitrogen is a liquid at negative 196 degrees Celsius. Well, what temperature is that, Kelvin? Well, I add the 273 to get 77 Kelvin. Well, it's a funny thing because he said, what if something is negative 274 degrees Celsius? I can tell you right now that absolute zero, the coldest that it gets, is 0 Kelvin. Okay? Molecules cease to move at 0 Kelvin. And that's why we call it absolute zero. So you will not see anything below negative 273.15 degrees Celsius. Now, here is the Fahrenheit formula. The big one is in the box. Don't worry about that stuff up at the top. Okay? Don't worry about that stuff up at the top. Worry about the stuff in the box. Degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. The Celsius formula, they're just showing you how they work it here. The main thing is the bottom one in the box. Degrees Celsius is equal to degrees Fahrenheit minus 32 in parentheses multiplied by 5/9. So what are you going to do first? Parentheses. Please excuse my dear Aunt Sally. P is parentheses. We do that first. So we take the Fahrenheit, subtract 32, and then multiply that by 5/9. Here is an example. A person with hypothermia has a body temperature of 29.1 degrees Celsius. What is the body temperature in Fahrenheit? Well, if you look at your Fahrenheit calculation, Fahrenheit is equal to 9/5 times degrees Celsius plus 32. So if you would do the math, 9 divided by 5, multiply that by 29.1, will give you 52.4. And then you add 32 to it. So hypothermia has a lower temperature. You'll see later on that hypo is lower. Hyper is higher. What is the normal temperature of a chickadee? Well, not what is. The normal chickadee temperature is 105.8 degrees Fahrenheit. What is that in Celsius? Go ahead and calculate that. What'd you get? A, B, or C? Oh, don't everybody scream it out at once. Oh, well, no wonder. A, B, or C. 1, 2, or 3? All right, that's a little better. 3, okay? 3. 41 degrees, 41.0 degrees Celsius. Here's another quickie. Go ahead and work this one. All right, you're not going to get me on this one. 1, 2, or 3?
2.
Final answer? 2. All right, 2. So hopefully these temperature conversions are pretty easy for you. Now, final thing that we're going to talk about today, you're going to need to use this on your lab Friday, okay? It's accuracy and precision. All right? Accuracy and precision. It says up here, we have 3 targets with 3 arrows to shoot. My first target, right there, my 3 arrows. There's my second. There's my third. Now let's talk about accuracy and precision. Okay? How do they compare? Look at the first target. Are those accurate? Absolutely. Okay? They're all grouped together, aren't they? Are they precise? Absolutely, because they're all on the bull. Middle target, are those accurate? They are accurate. Where are they grouped? They're all together. They are accurate. Are they precise? No, because they're not anywhere near the bull. Look at the third one. Are those accurate? They're not grouped, are they? Are they precise? No. Okay? So that is accurate precision. Okay? Did we get them mixed up? All right. Yeah, okay. All right. They are precise, but they are not accurate. Okay? I think I did say that wrong. Okay? So precision is what? Okay? Precision is being able to hit the same area on the target over and over. Accuracy is what? The ability to hit where you want to hit the bowl. All right? So, let's not get those confused. Both accurate and precise. This is not accurate. This is not accurate, nor is this. Okay? This is precise because they're all grouped. This is not precise because there's no grouping. Okay? So, could we now define accuracy and precision? Okay? You might want to write that in your notes so you don't get that confused. Get the definition for accuracy, definition for precision, because you're going to have to do that. Now, it's easier to remember them when thinking about shooting at a target like this. When you do it next Friday, or no, this Friday, when you do it this Friday, you're going to be determining whether they're accurate and precise based on numbers of your periodic table. Okay, densities on the periodic table. Okay? I think maybe we got one more slide. Nope. That is it for our slides today.